But that's just one thing to look at. A cell by itself isn't going to do much. If we brought in a brain cell individually, it's not going to have any interesting behaviors. It's just sitting there. So one thing to do is to study groups of networked cells or small-scale neural networks. So frequently, cells that engage in a similar function at the same time will increase communications with each other. There's some simple phrase for this. Oh, yeah, fire together, wire together. That's it. That is actually the phrase. So cells that are engaged in the same part of the brain and activity will develop connections and begin to function as groups. These are the things that can't be specified in the genome because there's way the heck too many cells. So there's a functional principle of the brain in which wiring occurs dynamically as a function of brain activity. For those of you who like math, these kind of you can also like mathematically simulate the ways in which these neural groups form. And one level of brain, which we're not going to spend a lot of time on here in 2 days of intro psychology, one level of brain study is at the very detailed level of these individualized, which you can then study with proper techniques, development of neural networks. And then finally, the brain doesn't really just look like that. As we showed you already, the brain looks kind of more like that, with an underneath wiring diagram that's this, as if underneath a city that looked just like a city, there were, 10 million phone cables that each branched out at each building into 10,000 little rooms. And that's how the people were actually communicating, but you couldn't see it because it was under the street. Quite similarly, this kind of picture doesn't really show you what the brain's doing because a bunch of it is down here and its connections between parts, a lot of them, as we saw in the section on consciousness, running through the thalamus, described as kind of a relay station. So when you're studying the brain and ask what are people doing, they aren't doing any one thing. There are techniques for studying activity in individual cells. There are techniques for studying and modeling the formation of neural groups. You can use just plain old gross anatomy to see subparts of the brain. And you can use a variety of techniques, again, including mathematical modeling techniques, to study the brain functioning as essentially as an information network as a whole.